Okay, so what we're going to be looking at today is something called the power law of logarithms. And what it's going to help us do is evaluate for the exponent in a logarithm. So here's our first example. We're looking at evaluating each of the following logarithms. And the way we've done this up to now is, in order to evaluate this, the base and the base of the answer have to be exactly the same. So the base of the logarithm and the base of the answer have to be written exactly the same. So I'm going to rewrite the base of the answer part as 4 to the exponent 2. So 16 can be rewritten as 4 squared. And all of this is to the exponent 5. Now if I use my exponent laws that I know from grade 9, when I have an exponent applied to another power, I multiply the exponent parts together and I get an exponent of 10. And so because the base of the logarithm and the base of the answer part are the same, I know that 4 to the exponent 10 will give me the answer that I need. So the final answer here is 10. I'm going to do something similar here, except I'm multiplying 5 with the logarithmic part that's following it. So this is 5 times the log of base 4. 16 I'm going to rewrite as 4 squared. And if I look at the logarithm part, the exponent in which I need to apply to the 4 to get an answer of 4 squared is 2. So I know the answer part here is 2. And 5 times 2 gives me 10. And if you notice the two questions that we were looking at in part A and part B, they look fairly similar. And their answers are actually exactly the same. And we're going to see how the power law of logarithms is related to this warm-up question. Now, question number 2 is a little bit different. You're asked to solve for x. So, when you are trying to solve for x, and we're going to look at another way of doing this question later on in the lesson. When you're trying to solve for x, right now all I can do is trial and error. And I know that 3 to the exponent 2 gives me an answer of 9. And 3 to the exponent 3 gives me an answer of 27. So, knowing that the answer I'm looking for is an answer of 10, and 9 is much closer to 10 than 27 is, I can try to use my calculator and play around a little bit to try to solve for the answer for x. So I'm going to do 3 to the exponent 2.1, and I don't know if you can see this, and I get a result of 10.045. So that's pretty close. So I have 3 to the exponent 2.1 is equal to 10, and so I know that x is equal to 2.1. Okay, so today we're going to be looking at logarithms again. So just a quick little reminder of some information you know about logarithms. Logarithms are useful for solving for an unknown exponent in an equation. Okay, so for example, if I have 3 to the exponent x equals 10, I can rewrite this as a logarithm. So my base of 3, the answer is 10, and the answer that I get when I solve the logarithm represents the exponent to which 3 must be raised to get a result of 10. Okay, so in the warm-up we use trial and error to solve for the value of x. In this lesson we will find a more efficient way to solve for an unknown exponent using logarithms. So we're going to look at the power law of logarithms, and this is what we saw actually in the warm-up in the first question. So the power law of logarithms states that log base b of x to the exponent n is equal to n times log base b of x. So what you'll notice is that the exponent part here has been used as the coefficient of the logarithm here. Okay, so if we think back to the warm-up, we had log base 4 of 16 to the exponent 5, and that was equal to 5 times the log of base 4 of 16. And so the exponent part on the result, 16, was removed and was rewritten as the coefficient in the next statement. And this just makes your work a little bit easier. We were able to solve both of these, but the second second one's a little bit easier to work with than the first one. Okay? Some of the conditions on the power law of logarithms include b has to be greater than 0, and that's the same condition we looked at before. B cannot equal 1, again, same conditions. X must be greater than 0, which means that the value of x here has to be a positive answer. We know that as well. And n is an element of all real numbers, so it can be any positive or negative whole number or a decimal number. So here it is from the warm-up again. We were able to evaluate the left side and the right side, but the right side here is just a much simpler way of solving. And this will come in very handy when we have questions where you might get something like log base 2 of 8 to the exponent t. Okay? This is where the power law of logarithms will come in handy, since the exponent part is actually the variable that you are trying to solve for.